Hello students, I am AB said. Let us solve some sums for forthcoming JEE Advanced examination on parabola. In this question, it has been given that PQ is a normal chord of the parabola y square equal to 4ax at P. So let's draw one parabola first. Y square equal to 4x parabola. Suppose this is a parabola y square equal to 4x and PQ is a normal. So P is the point. Suppose a T1 square to a T1 and the normal is, suppose this is PQ. So this point is suppose a T2 square to a T2. Now according to the question, through P a line drawn parallel to AQ meeting x-axis at R. So this is A and this is AQ. So through P a line is drawn parallel to AQ meeting x-axis at R. On the x-axis y is coming 0. Therefore we know that T2 equal to minus T1 for normal chord minus 2 by T1. Therefore we can say T1 T2 equal to minus T1 square minus 2. Now equation of line through P we are getting here, which is parallel to AQ. So parallel to AQ means the slope of AQ is 2AT2. So slope of AQ is 2AT2 y2 minus y1 by x2 minus x1 AT2 square minus 0. So this is coming to be 2 by T2. Therefore equation of the line through P is given that y minus 2AT1 equal to 2 by T2 into x minus a T1 squared. So in this case put y equal to 0 to get the point because it is on the x-axis. Therefore we are getting x equal to a T1 square minus a T1 T2. Therefore a T1 square minus a into minus 2 minus a T1 square. In this case T1 square. It is coming from here. Just I am taking this value. This value I am taking. Therefore we can get here we are getting from here what is coming, that it is coming to be 2a plus 2a T1 square, that is 2 into a plus a T1 square. So we know that a plus a T1 square x plus a, that is for PS equal to PM. So for point to the directrix, therefore it is twice the focal distance. So the option number is coming to be here C. Let's go to the next sum. If D is the distance between the parallel tangents with a positive slope to y square equal to 4x and x square plus y square minus 2x plus 4y minus 11. So one is the circle and one is the parabola. So let's do one thing. Equation of the tangent to y square equal to tangent to y square equal to 4x is given that y equal to mx plus a by m. A is here 1 because y square equal to 4x. So no a is 1 here. And again tangent to x minus 1 whole square plus y plus 2 whole square equal to 16. Parallel tangent, therefore the having the slope also same. So we know that y plus 2 equal to m into x minus 1 plus 4 into root over of 1 plus m square. That formula y equal to mx plus a into root over 1 plus m square. So instead of y just replace y plus 2 and instead of x replace x minus 1. Now the distance between the tangents distance between the tangents equal to actually c2 minus c1 by a square plus b square. So if we apply this formula, 4 into root of r1 plus m square minus m minus 2 minus 1 by m total divided by root of r1 plus m square, and if we apply, if we calculate, if we divide, we are getting 4 minus of 2 by root of r of 1 plus m square minus root of r of 1 plus m square by m. So this bracket portion is always positive, therefore as m greater than 0 we can say d is less than 0. So the option number is coming to be C. Option number is C. Let us solve the next sum. If P be a point on the parabola y square equal to 3 into 2x minus 3 and M is the foot of the perpendicular drawn from P on the directrix of the parabola, then length of the side of the equilateral triangle we have to draw. So let's draw one rough diagram. This is the axis, just I am drawing one rough diagram, and M is the foot of the perpendicular drawn from P on the directrix. So P is a point and M, this is M, foot of the perpendicular, and this is the S. So if it is S, so according to the question, this is the equilateral triangle and we have to get the length of the side. So what have we done? Y square equal to 6 into x minus 3 by 2. So equation of directrix is x minus 3 by 2 equal to minus 3 by 2. Therefore x equal to 0 and focus is 3, 0. So let P be, let us consider y equal to 3t. If we take y equal to 3t, x will be, just put y equal to 3t. So y square equal to 3 into 2x minus 3. So y equal to 3t if we put, we are saying that x is coming 3 by 2 plus 3 by 2 t square. Therefore we can write 3 by 2 plus 3 by 2 t square. After getting this result, let us find the value. So the coordinate of M, since we are dropping the line to the direct M, so the point M is here 0, 3t, because focus directrix is the x equal to 0, it means y axis, directrix is the y axis, therefore the M point is the 0, 3t. Now we can say MS equal to what? The distance between S and M. So 3 square, it means 9 plus 9t square, and MP equal to, we are getting 3 by 2 plus 3 by 2 t square. Therefore equating them on the both side, we are getting 9 plus 9t square equal to 3 by 2 plus 3 by 2 t square whole square, removing the root over. So we are getting here 1 plus t square equal to 4. Therefore length of the side, length equal to, we are getting to be 6. From this we are getting t as root 3. Let's solve the next sum. A tangent is drawn to the parabola y square equal to 4x at the point P, whose abscissa lies in the interval 1 to 4. The maximum possible area of the triangle formed by the tangent at P, ordinate of the point P and the x-axis. So let's draw y square equal to 4x. Now let's see one thing. Suppose let us consider one tangent. 80 square to 80, in this case a equal to 1, therefore t square comma 2t. If we drop the ordinate, this is n, suppose this is p, and this is a is minus t square comma 0. So in this case, the equation of tangent is ty equal to x plus at square, we can write. So slope of the tangent is 1 by t. Therefore area we can write this as, suppose area a equal to half base into altitude, so in this case half an into pn, that is coming half into 2t square into 2t, so this is coming 2t cube, so we can write this as 2t square whole to the power 3 by 2. So given t square belongs to 1 to 4, so a max is obtained only when t square equal to 4. Therefore a equal to maximum area, which is a, that is put t square equal to 4, we are getting to be 16. So final answer is the option number B. Let us go to the next sum. If the angle between the tangents from the point lambda comma 1 to the parabola y is equal to 16x be 90 degree pi by 2. So we know that there is a very big property, very important property, that they meet, tangents are perpendicular, then they intersect on the directrix. Therefore lambda 1 is on directrix. Therefore in this case directrix is what? A equal to 4. So directrix, equation of directrix is what? X equal to minus 4. Therefore lambda equal to minus 4, because it is a x coordinate of the lambda. Lambda is the coordinate of the x. Let's go to the next one. The locus of a point on the variable parabola y is equal to 4ax, whose distance from the focus is always equal to k. So there is a parabola, suppose, and let the point be at square 2at. Now according to the question, PS equal to a plus at square, because we know that PS equal to PM. So PM means a plus at square, so PS is a plus at square, and it is equal to k. In question it has been given. Let alpha beta be point, moving point. So alpha equal to at square and beta equal to 2at. Now we can do one thing, just divide. We have to eliminate t actually. So alpha by beta equal to t by 2. And if we put the value here, we can get a equal to beta square by 4 alpha. So substituting all these values, just suppose this is 1, substituting all these values in 1, we are getting just a into 1 plus t square, it is beta square by 4 alpha into 1 plus t square 4 alpha square by beta square equal to, we are getting what? K. And if we cross multiply, we are getting beta square plus 4 alpha square equal to 4k alpha. So final answer, instead of alpha and beta, put the value xy, 4x square plus y square minus 4kx equal to 0. Therefore here the option number is A. First option is the right option. Let's go to the next sum. There is a column matching. So let's match the column. One by one, let's solve. Suppose sum number A. For sum number 8, tangents are drawn from the point 2, 3 to the parabola y square equal to 4x, then the point of contact. So tangent to the parabola ty equal to x plus at square, which we know. It passes through the point 2, 3. This tangent to the parabola passes through the point 2, 3. Then we can write, therefore we can write 3t equal to 2 plus t square, and if we solve, t equal to, we are getting 1 or 2. T equal to 1 or 2. Therefore, point of contact is t square comma 2t. So we are writing that 1 comma 2 and or 4 comma 4. So here it is the option 1 comma 2, 4 comma 4. So A is related to Q and S. So we can say A is related to Q and S. Let's go to the sum number 2. That is B. Here what B is telling, from a point P on the circle x square plus y square equal to 5, the equation of the chord of contact to the parabola y square equal to 4x is y equal to 2 into x minus 2, then the coordinate of the point P. Let the point P be x1, y1. So let the point P be x1, y1. Therefore, chord of contact is as if tangent y into y1 equal to 2a into, in this case a is parabola is given to be y equal to 4x, that's a equal to 1, therefore 2 into x plus x1. Now we can say compare with, if we comparing with, we can write what was there, y equal to 2 into x minus 2. If we compare them, we are getting y1 equal to 1 and x1 equal to minus 2, which satisfying the circle x square plus y square equal to 5 also. Therefore, what is coming here? Minus 2 comma 1. Here option number R. So B is connected to R. Now let us go to the C. For C, P 4 comma minus 4 and Q are the points on the parabola x y square equal to 4x, such that area of the POQ is the 6. Then find the point of Q. This is a question. Let Q be 80 square to 80, A is 1, so t square comma 2t, and O already we know, and another point is what? 4 comma minus 4. Another point is 4 comma minus 4. P point is 4 comma minus 4 and O point is 0 comma 0. So it is very easy sum. Just what we have to get here, that area is 6. So let us find the area. So to get the area, we can use the determinant form as well as normal form, because O is there, origin is there. So 0 into whatever 0 plus 4 into x1 into y2 minus y3 plus 4 into 2t minus 0 plus t square into 0 plus 4 equal to 0, equal to 6 here, given to us 6. Therefore, if we calculate, we are getting t square plus 2t minus 3 equal to 0. Therefore, t minus 1 into t plus 3 equal to 0. Therefore, t equal to 1 or minus 3. Therefore, Q point, if we put the value, t is 1 when we put, we are getting t square comma 2t is Q point. Here it is Q. Q point is t square comma 2t. So, put t equal to 1 and another t equal to minus 3. Therefore, the points are, Q points are 1 comma 2 and 9 comma minus 6. So is there any point which is satisfying here? 1 comma 2 9 comma 6 means P comma Q. So C is related to P comma Q. Now let's go to the last D, the common chord of the circle and the parabola. So it is better in this case if we just satisfy with the points. We are seeing that 1 comma 2 is satisfying the x square plus y square equal to 5. 1 comma 2 is satisfying x square plus y square equal to 5, and also we are seeing that minus 2 comma 1 is also satisfying the circle. So in this case also just put the point Q and R. Therefore D is associated with the Q and R. Let's go to the next sum. If y equal to x plus 2 is any tangent to the parabola y square equal to 8x, the ordinate of the point P on this tangent such that the other tangent form it which is perpendicular to it. So really it's related to the very basic concept of the sum. Clearly P is the point of intersection of two perpendicular tangents. P is the point of intersection of two perpendicular tangents, and as we know that it lies on the directrix. So here 4a equal to 8, so a equal to 2, so equation of the directrix is x plus 2 equal to 0, therefore x equal to minus 2, therefore the point is minus 2 comma 0. So this is a integer type sum. So in this case we have to get the ordinate is 0, so answer is integer type sum, answer is 0. Let's go to another integer type sum. So in this sum it is given that let S be the focus of the parabola y square equal to 8x and PQ be the common chord of the circle. X square plus y square minus 2x minus 4y equal to 0 and the given parabola. Then the area of the triangle PQS. How to solve the sum? This is the area of the triangle PQS. So let's solve it. First of all, S be the focus of the parabola y square equal to 8x and PQ is the common chord of the circle. So let's draw one diagram, and in this case we are seeing that the circle is passing through the point 0, 0. So if we draw upon and the circle is this, circle is passing through the origin, this is S 2 comma 0. Suppose any point P, that is 80 square to 80, a equal to, here a equal to 2, so 2t square 40. Now let's see one thing, P, this P point, everybody, this P point is satisfying the circle also. So let us put the point P on the circle. We are getting that 4t to the power 4 plus 16t square minus 4t square minus 16t equal to 0. So if we take the t common, we are getting t cube plus 3t minus 4 equal to 0. So t equal to 0, and this is the cubic equation. In cubic equation, if we put t equal to 1, we can use the hit and run method, vanishing method, whatever you say. We can just put t equal to 1, it is getting satisfied. So t equal to 0 or 1. Therefore, P point is 2 comma 4, because it cannot be 0, 0. 0, 0 is the origin already, their point of contact. So let P is the point 2 comma 4. Therefore, area of PQS equal to half into 2 into 4. This is coming to be 4. Let's go to the next sum. Let's solve one JEE advanced question. If the normal of the parabola y square equal to 4x drawn at the end point of the lattice rectum are tangent to the circle. So it's very simplified sum. So in this case, normal of the parabola, so diagram is not so much necessary. So let's do one thing. These are end points of the lattice rectum, suppose A and B. So A to A and A minus 2A. So 1, 2 and 1 comma minus 2. So in this case, we can do one thing, that if we do dy dx, we are getting 1. Therefore, the equation of the normal, is at point A is y minus y1 equal to minus dx dy into x minus x1. Therefore, x plus y minus 3 equal to 0. So the r is the distance of the line from the point center. So if suppose this is a circle and this is a line, so r is the distance here. So r is the radius. Therefore, we can write this as r equal to distance formula 3 minus 2 minus 3 by root over of 2. Therefore, it is coming to be root 2. So r square equal to 2. Let us go to the next sum. Let curve C be the mirror image of the parabola with respect to the line. So mirror image of the parabola is also the mirror image, or also the parabola only. If A and B are the points of intersection of C with respect to the line y equal to minus 5, then the distance between A and B. So how to solve this sum? Let this is a parabola, this is a line, and suppose this is a C. This curve is a C. And let P be any point y square equal to 4x, that is t square comma 2t, and P dash to be the mirror image, suppose alpha comma beta. So using the formula, mirror image formula, alpha minus t square by 1 equal to beta minus 2t by 1 equal to minus 2 into t square plus 2t plus 4 total divided by a square plus b square, that is 2. Therefore, from this we are getting first and third if we equate. So t square is getting cancelled, alpha equal to minus 2t minus 4, and second and third if we equate, that is t part will be cancelled, we are getting beta equal to minus t square plus 4. According to the question, this is coming to be minus 5. Therefore, t equal to plus minus 1. So put t equal to 1 and t equal to minus 1. So A point is coming to be minus 2 minus 5, and B point is coming to be, in this case, what? Minus 6 minus 5. Therefore, BA equal to 4. So this is the question of integer type came in IIT examination. Let us go to the next one. 3 normals drawn from any point to the parabola y square equal to 4ax cut the line x equal to 2a in points whose ordinates are in AP. It means 3 normals are drawn from a point. The point is called the co-normal point. The point is actually the co-normal point. Suppose this point is the co-normal point, and which cut the line. So first of all, let us calculate, and these are very important. And suppose this point is feet of the normals. So this is A, this is B, this is C, and this is A m1 square minus 2A m1. Similarly, m2 similarly m3. Therefore, equation of the normal at a m1 square minus 2a m1 is y equal to mx minus 2am minus am cube. This formula for the normal, we know this properly. Now solving with x equal to 2a. If we put x equal to 2a, so y is coming to be, if we put x equal to 2a here, so these two are getting cancelled and y is coming minus am1 cube. Therefore, we can write this as point of intersection is what? X is 2a and y is minus am cube. In this case, am1 cube and that is am2 cube and am3 cube. Okay, so we can write this as the calculation like this. So am1 cube we can write, and for our other it is am2 cube, and third is the am3 cube. So we can say according to the question they are in AP. So minus am1 cube plus am2 cube equal to minus 2a, suppose am3 cube. But for co-normal points, we know that if we make the cubic equation, we know that the sum of the roots equal to 0. It means m1 plus m2 plus m3 equal to 0, which we know. So we can write this as m1 plus m3 equal to minus m2. Now we can say here that 2m2 cube equal to m1 cube plus, so in this case we can write from here, if we just cancel the minus and a, we are getting 2m2 cube equal to what is coming here, m1 plus m3, m1 cube plus m3 cube, a cube plus b cube formula. So m1 square plus m3 square minus m1 m3 we are getting here. I have to write some part. So if we use some another ink, we can get here. And just if we put m1 plus m3 equal to minus m2, if we put here m1 plus m3 as minus m2, here if we put, and we are getting now 2m2 cube equal to minus m1 square minus m3 square plus m1 m3. Also we know that m2 square equal to m1 square plus m3 square plus 2 m1 m3, and from these two we can say, we can say, if we just divide, we are getting 3m2 square equal to 3m1 m3. Therefore final answer is coming to be, if we divide, we are getting m1 by m2 into m3 by m2 equal to 1. So answer of this question is coming to be 1. Let's go to the next sum. A chord is drawn from the point P to the parabola y equal to 4x, which cuts the parabola at A and B if PA into PB equal to 3 mod P. We have to find the max angle. So in this case, let's draw one chord. So this is P, A, B, and P is 1, T. So in this type of cases, we have to apply the symmetrical equation or parametric equation. Let the equation of line PAB is x minus 1 by cos theta equal to y minus t by sin theta equal to r. Therefore, x equal to r cos theta plus 1 and y equal to r sin theta plus t. Okay. This line will meet the parabola at A and B. So let us solve x and y with parabola. Therefore, we are getting here, if we put the point y square equal to 4x, r sin theta plus t whole square equal to 4 into r cos theta plus 1. Therefore, make one quadratic equation with r, r square sin square theta plus 2r. If we take t sin theta minus 2 cos theta plus t square minus 4 equal to 0, and product of the root is c by a. Therefore, PA into PB equal to c by a. In this case, t square minus 4 by sin square theta. According to the question, this is coming to be 3 mod t. Here it is given to be 3 mod t. Therefore, let's proceed. 3 mod t. So we can write here mod of t square minus 4 by 3t equal to sin square theta, and sin square theta we know less than equal to 1. So mod of t square by 3 mod t less than equal to 1. So we can write this as t square minus 3 mod t minus 4 less than equal to 0. Therefore, we can write mod t plus 1 if we factorize, and mod of t minus 4 less than equal to 0. Mod t cannot be negative. Therefore, mod t less than equal to 4. Therefore, this is the maximum value of it. Therefore, answer is coming here 4. Let's solve the next sum. From the point 1 comma minus 2, tangent lines are drawn to the parabola y square equal to 4x if the area of the triangle formed by the chord of contact and the tangents is a, then the value of a by root 2. What is the value of a by root 2? Let us find here. So first of all, let's draw one rough diagram from the point. Suppose this point is P minus 1 comma 2. Tangent lines are drawn to y square equal to 4x. So this is P and this point is Q. So chord of contact with respect to P is as if it is a tangent. So y equal to x minus 1, and solving this with the 1 and y square equal to 4x. If we solve, we are getting what? Y square equal to 4y plus 4. Therefore, y square minus 4y minus 4 equal to 0. So y equal to minus b plus minus root over b square minus 4ac by 2a. Therefore, y equal to coming 2 plus minus 2 root 2. And putting this value in 1, we are getting x equal to 3 plus 2 root 2, and if we put the value negative, and 3 minus 2 root 2. Therefore, In this case, P point, suppose 3 plus 2 root 2, comma 2 plus 2 root 2, and Q point, suppose it is coming 3 minus 2 root 2 and 2 minus 2 root 2. Therefore, PQ square is coming to be, and this integer part is getting cancelled, 4 root 2 whole square plus 4 root 2 whole square, and this is coming 64. Therefore, PQ equal to 8, and according to the question, it is coming, suppose let's draw one. This point is P and this point is, so suppose this point is some P dashed considered. This point is suppose P, we have taken twice as P, so suppose this is P dashed. So we can write this as P dashed PQ, and the line is x minus y minus 1 equal to 0. So if we go to the distance, perpendicular distance formula, if we are getting this d equal to minus 1 minus 2 minus 1 by root over a square plus b square, that is coming 2 root 2. So we can get, just I have to get some area for writing the sum. Therefore, we can write this as area of the triangle is half into base into altitude, that is coming 8 root 2. Therefore, a by root 2 equal to 8. Therefore, final answer is coming to be 8. Let's go to the next sum. A line through the origin intersect 5y equal to 2x square minus 9x at 2x square minus 9x plus 10 at 2 points, whose x coordinate add up to 17. Find the slope of the line. So what to do? Let the equation be a line through the origin y equal to mx. Let the equation be y equal to mx, and solving this number 1 with the parabola, we are getting, just put it here, 5mx equal to 2x square minus 9x plus 10. So make one quadratic equation with x, 2x square minus x into 9 plus 5m plus 10 equal to 0. Therefore, sum of the roots is coming to be minus b by a. So 9 plus 5m by 2, this is coming to be 17. Therefore, 5m equal to 25. So am equal to 5. So answer is coming to be 5 here. Let's solve the next one. This equation represents the parabola, and we have to find the value of k. So in this case, let's do one thing. Let us take common 13 square. So x minus 1 by 13 whole square plus, if we just take similarly y minus 1 by 13 whole square equal to k into, if I write like this, five x minus 12y plus 1 by root over 5 square plus 12 square whole square. We have taken extra 13 square, so balance by 13 square, and this 13 square is getting cancelled this side in the left hand side. And remember, this is the focus and this is the directrix. Actually, it is PS equal to PM. So according to the question, K equal to 1. Because in parabola, eccentricity is coming to be 1. Let us do the next one. to find the length of the common chord of the curve y square minus 4x minus 4 equal to 0 and a 4x square plus 9y square equal to 36. So one is the parabola and one is the ellipse. So first of all, let us solve them. Let us solve them. So 4x square plus 9 into 4x plus 4 whole square equal to 36. If we calculate them, we are getting x square plus 9x equal to 0. So x equal to 0 and minus 9. And put them in y square equal to 4x plus 4. Put them, we are getting y equal to plus minus 2. Therefore, common chord is 4. Let's do the next sum. Find the locus of the point of intersection of two tangents of parabola y square equal to 4ax, which with the tangent at the vertex form a triangle of constant area 4. How to solve this sum? Let's see. So y square equal to 4x, let's draw the diagram here. Locus of the point of intersection of the tangents. Let P point is 80 square 280 and Q point is 82 square 282. So equation of tangent at P, T1 means 81 square 281, 2a T1 into y into y1 equal to 2a into x plus x1, x plus a T1 square. So put x equal to 0. Put here x equal to 0. So suppose this point, this is the point we are getting here. Suppose this is something, this is R, this is T, this is W. Tangent at the vertex is the y-axis. They are putting x equal to 0 here. We are getting T is the point. We are getting 0 comma AT1. Similarly, W is the 0 comma AT2. Now we can get area. Area of RTW we have to find. So in this case we know that R equal to point of intersection of the tangents A T1 T2 A T1 plus T2, point of intersection of the tangents. Therefore we can write here area is half AT1 minus AT2 into AT1 T2, which is the x coordinate of the R. According to the question, this is coming to be 4. So a square T1 minus T2 into T1 T2 equal to 8. Let us give it number 1. So R coordinate AT1 T2 and AT1 T2. Suppose RB, its locus is needed. So suppose RB some x1 y1. So according to the question, x1 equal to AT1 T2 and y1 equal to a into t1 plus t2. Therefore, we can write this as t1 t2 equal to x1 by a. Actually, you have to eliminate t1 and t2, and t1 plus t2 equal to y1 by a. So, how to eliminate them? Let's see. Let us see how to eliminate them. Now, in this area, I am putting here that t1 plus t2 and t1 t2, but here it is the t1 minus t2. So let us do the whole square here. Let us do the whole square here. In this case, let's go to the whole square. If we do the whole square, we are getting a to the power 4 into t1 minus t2 whole square, that is t1 plus t2 whole square minus 4 t1 t2. Exactly, we have to get in terms of t1 sum of the root and t1 plus t2 and t1 t2 into t1 t2. t1 t2 can be written as here x1 square by a square equal to, if we do the whole square, it is coming 64. So in this case, t1 plus t2 and t1 t2, if we put the value, we are getting a square, a square is getting to be cancelled. So we are getting a square into y1 square by a square minus 4 x1 by a into x1 square equal to 64. Therefore, we can get it y square minus 4ax, instead of x and y, if we put the value, into x square equal to 64. So, in this case, find the locus of the point of intersection of the two tangents of the parabola, which is a constant area. So, this is the locus. So, the final answer is this. Let's go to the next sum. On the axis of any parabola, there is a certain point T which has the property that if a chord PQ of a parabola be drawn through it, then 1 by PT square plus 1 by QT square is same for all positions of the chord. Find the point T. Let's draw one comfortable diagram. So, according to the question, if we draw the diagram, we are getting suppose point T is T comma 0. And this is the point P, this is the point Q. So, put T plus R cos theta using the symmetrical formula and R sin theta in the equation of the parabola. We are getting what? R square sin square theta minus 4 cos theta R minus 4t equal to 0. It has two roots, R1 and R2. So, suppose R1 equal to PT and R2 equal to QT, or you can say it is to be minus QT also. Therefore, 1 by PT square plus 1 by QT square equal to 1 by R1 square plus 1 by R2 square, that is coming to be R1 plus R2 whole square minus 2 R1 R2 total divided by R1 R2 whole square. So, if we put the value here, sum of the root and product of the root, we are getting 16 cos square theta by sin to the power 4 theta plus 8t by sin square theta total divided by R1 R2 whole square. It means 16 t square by sine to the power 4 theta. If we calculate properly, we are getting here 16 cos square theta plus 8t sine square theta divided by 16 t square. So this is independent. According to the question, it has been given that same position for all chord. So this value is independent of theta. It is only possible that 8t, if it is only possible that if and only if 8t equal to 16, therefore t equal to 2, and which is the final answer.